So this next section is a little bit more challenging because we're working with numerators other than 1. Previously, we had 1 in each of our numerators, 1/2, 1/4, 1/3. Now we're going to work with slightly more complicated fractions that have different numerators. Like here we have 2/3, here we have 2/5, and here we have 4/5. But you can figure it out. Let's take a look at the scenario. Suppose you are organizing games for a field day event that lasts 4 hours. Determine how many games you can organize for the event if each game lasts the given amount of time. Draw a diagram and write the appropriate number sentence. All right, in this case, exercise A is the hardest one, so let's do that one together. We're really going to do the same process that we did last time. What I want to do is divide these bars into thirds. Each of the rectangles represents an hour, so let me divide it up into a third of an hour. And my question is, how many times can I get 2/3 of an hour to fit into 4 hours? Let's see. I'm just going to change my marker color here and maybe make it a little bit bigger. Okay, so 2/3. There's a 2/3. There's 2/3. There's 2/3. There's 2/3. There's 2/3. And there's 2/3. Aha, okay. So how many blocks of 2/3 do I have? 1, 2, 3, 4, 5, 6. So now I can write a division fact. I can say that 4 divided by 2/3 equals 6. 2/3 goes into the number 4 6 times. That's going to be the process you're going to want to use with these other models. Here you're saying, how many times can I fit 4/5 of an hour into 4 hours? What about 2/5 of an hour? So you're going to pause the video and you're going to do B and C. Let me just remind you of how the steps work. You use the denominator to decide how to divide your blocks. So when my denominator was 3, I divided these into thirds. Here your denominator is 5, so you'll divide these into fifths. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So each of those will be divided into fifths, and then you will complete your model after that. Pause the video, make your models, and come up with an answer to each of these questions for B and C, and do this task on your own, please. All right, if you've hit play, you're ready to talk about your models. So in the model that we did together in choice A, we learned that we could have 6 sessions or 6 games that each last 2/3 of an hour. Now choice B shows us, what if we make them really short games? What if they're only 2/5 of an hour? Well, then we could have 10 of them. In choice C, what if we make our games a little longer? What if they're 4/5 of an hour? That's almost an hour. Then how many games could we have? Then we could have 5. We are going to skip choice D, but I do think that we see the connection between the model and the fact families that we're using to solve these fraction division problems. So let's talk about some work that you guys already did. You guys have actually already done 4 divided by 1/3. Let me show you where. Let's see, 4 divided by 1/3. We did that right here, and we said it was 12. So let me write that down here. We said 4 divided by 1/3 is 12. We also already did 4 divided by 2/3. Here it is. 4 divided by 2/3 is 6. Now, how are those two quotients related? What do you think? That's right. The quotient of 4 divided by 1/3 is twice as big as the quotient of 4 divided by 2/3. When we divide by 1/3, we get 12. When we divide by 2/3, we get 6. Now, looking at a previous example, we know that 6 divided by 1/2 is equal to 12. One pattern that you might notice is that 6 times 2 equals 12. 6 divided by 1/2 is equal to 12, And 6 multiplied by the denominator here is equal to 12. That's just a little shortcut that works when your numerator is 1. We're going to explore why that works pretty soon here. In the meantime, pause the video and work with a partner for 4 minutes to answer choices A, B, and C here, exercises A, B, and C. And you can use this trick. Remember, our numerator is 1 in each of these cases. We have a 1, and a 1. So what I want you to do is multiply 6 times 4. Multiply 6 times 8. Multiply 6 times 16. We'll see why this works in a little bit. The important thing right now is that you know that it does work and that you use it to find the quotient for these equations, for these expressions. All right, good work. 6 divided by 1/4 is 24, the same way 6 times 4 is 24. 6 divided by 1/8 is 48, the same as 6 times 8 is 48. And 6 divided by 1/16 is 96, the same way 6 times 16 is 96. Good job finding the value of these expressions. All right, let's see what we can do with this. We're going to have a little bit of a debate here. Jamila is throwing a small party. She has 4 pizzas and decides that everyone at her party should receive a serving size that is 3/5 of a pizza. Jamila says that she has 6 2/3 servings, but Davion says she has 6 2/5 servings. Draw a diagram of the situation and solve for the quotient to determine who is correct. Explain why the other person is not correct. So we're going to do this task individually. In a minute, you're going to pause the video. You're going to read the question again on your own. You're going to create a diagram, and then we're going to have a little bit of a debate as a class. For now, pause your video, and I want you to read, think, and draw. Go. Okay, if you've hit play, that means you're ready for a debate. First, we need one person to explain why Jamila is right, if somebody who believes that Jamila is right. If you believe that Jamila is right, it's your turn to explain. Pause the video and let's hear your thinking. All right, if you've hit play again, that means you're ready to hear the other side of the story. We need somebody in the class to explain why Devin is right. Devin says that she has 6 2/5 servings. If you agree with Devin, now is your opportunity to defend your position. Well, that certainly was a lively debate. Now that you've had a chance to discuss, I am going to pause the video and show you my diagram. First, I drew a purple rectangle and I divided it into 4 sections. And then I divided each of those sections into fifths. That's what the green lines are. Then I drew boxes around sets of 3 because each person is going to get 3/5 of a pizza. So I had 1, 2, 3, 4, 5, 6 complete servings. Now, of course, both Jamila and Devin agree about this. They both agree that there's 6 whole servings. What they disagree about is how much of a serving is this? And the way that you should think about that is, remember, a whole serving of pizza is this. What we have left over is that. In other words, the part that's remaining is 2/3 of a serving. So Jamila is correct. There are 6 2/3 servings of pizza here. Okay, now that you guys know a lot about pizza, here's another one for you to solve. This time, go ahead and pause the video. We're not going to have a debate. I'm going to let you work with a partner. So get with your partner, pause the video, set a timer for 4 minutes, and see if you can figure out Jonathan's situation. All right, you've hit play, so we must be ready to talk about Jonathan and his pizzas. First, we need to draw 4 pizzas for Jonathan. There they are. Now, he has decided that everybody should get 3/4 of a pizza. So we're going to divide these into fourths. There we go. And then each person is going to get 3/4. There's a serving. There's a serving. There's a serving. There's another serving. There's another serving. And we have this little bit left over here. So how many servings does Jonathan have? If you said 5 1/3, you're right. He has 5 1/3 of servings of pizza.